Good morning, students. Today we are going to read the fractional distillation. That is a method of the purification. And this is a question particularly for paper number 4 chemistry subject. Paper number 4 is alternate to practical. That is in short form called ATP. So concentrate yourself. We are going to read fractional distillation today. Fractional distillation is used to separate two or more miscible liquids with different boiling points. So two liquids which are mixed with each other will be separated through fractional distillation. This is very important method. The liquids are distilled out in an ascending order of the boiling point. So it means the liquid with the lowest boiling point is distilled first, while the liquid with the highest boiling point is distilled last. So in the industry, fractional distillation is used to separate petroleum into various useful fractions such as petrol, diesel, kerosene, lubricating oil, and bitumen. And other use in the industry of the fractional distillation is to obtain nitrogen from liquid air to be used in the Haber process for the manufacture of the ammonia. And other use in the industry of the fractional distillation is to obtain wine, beer, whiskey, and other types of the liquor from fermented alcohol. So we are going to understand this topic, fractional distillation, through an example. To separate a mixture of the ethanol, boiling point 78 degrees C, and water, boiling point 100 degrees C. So here you can see two liquids which are miscible with each other, having different boiling points, will be separated through fractional distillation. So the procedure is, look here, the liquid mixture is poured into the distillation flask as shown in the figure. So here is a flask in which the mixture will be put. The mixture is of ethanol and water. So look now the apparatus. Here is the fractionating column which is having the glass beads. The function of the glass beads is to increase the surface area so that the evaporation and condensation process can take place again and again. So into the flask you can see here are the boiling stones. So the function of the boiling stone is to distribute the heat into the liquid uniformly. Here is the Bunsen burner. You will heat the mixture with a low flame. Again, the function of the low flame will be to distribute the heat uniformly. Otherwise, if the flame is high, the heat will be concentrated at one place. So here you can see now the thermometer. The thermometer's bulb should be in parallel with the exit of the condenser. Here is the condenser. So the condenser, the function of the condenser will be to convert the vapors back into the liquid form. And here is the collecting vessel. So first, when the temperature will be raised, because this is a mixture of the ethanol and water, ethanol's boiling point is 78 degrees C and water's boiling point is 100 degrees C. So when the temperature will rise, ultimately the ethanol will boil first. Its vapor will be raised into the fractionating column, and from here the vapors will go into the condenser. And then the vapors of the ethanol, when they will come into the condenser, will be converted back into liquid, and that liquid will be collected in the collecting vessel. So look now, ethanol distilled here, and now you will replace the collecting vessel and an empty collecting vessel will be put here. So when all the vapors of the ethanol will be evaporated, then the temperature will again go to rise. So when the temperature will become 100 degrees C, the water will boil now and the vapors will go through the fractionating column into the condenser, and again the vapors will be converted into the liquid and that will be collected in the collecting vessel. So this is how the ethanol and water will be separated from each other through the fractional distillation. And here are the steps. So look now, add a few pieces of the boiling chips. So the function of the boiling chips is to distribute the heat uniformly. the liquid mixture is heated and brought to boil. Both ethanol and water changes to vapor. The more volatile ethanol vaporize more easily, producing more ethanol vapors in the vapor phase. The vapor rises up the fractionating column. The glass beads provides the large surface area so that the vapor can undergo repeated condensation and vaporization as it rises up the fractionating column. The first vapor to reach the top of the fractionating column will be ultimately more volatile one, that is the liquid with the lower boiling point. Ethanol will distill over when the thermometer reads a constant temperature of the 78 degrees C. So first ethanol will boil. So when all the ethanol has distilled over, the temperature will rise again, and now the receiver is changed to collect water, which will distill over at 100 degree C as shown in the heating curve below. So this will be the heating curve. First the temperature will be rise, and when the 78 degrees C will be reached, ethanol will be distilled out, and when all the vapors of the ethanol will be distilled out, temperature will go rise again, and when it will reach 100 degrees C, the water will be boiled, and water vapors will be passed through the condenser, converted back into the liquid, so water will be distilled out. So this will be the heating curve of the whole process. So I hope so this will be much more easy and interesting for you to understand and learn now. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.